All right, good afternoon, everyone. My name is Ensign Rachel Seeberger, and I will be briefing you all on my thesis titled, A New Simulation Optimization Model for Wildland Fire Resource Prepositioning. My advisory team is Dr. Javier Samron and Dr. Gerald Brown. Wildfires are a growing problem across many regions of the United States. Every year, they burn millions of acres, destroy thousands of buildings, and cost billions of dollars in damage. In California, many of us witnessed this past year's unprecedented wildfire season. In 2020, over 4 million acres were burned in the state. This area is actually larger than the state of Connecticut and breaks the statewide burn record set in 2018 by over 2 million acres. So how do we prevent wildland fires? 90% of wildfires are actually contained through what we call initial attack. Initial attack is the rapid and heightened response of the first resources that arrive to the scene of a fire. We can improve the effectiveness of initial attack by prepositioning resources where fire danger is higher. This is called augmented staffing. In 2018, the Los Angeles County Fire Department reached out to the Naval Postgraduate School seeking a decision tool to guide their augmented staffing plans. We have developed and provided that tool, and Los Angeles County Fire Department is currently using it every day. We want to emphasize that resource prepositioning is not unique to firefighting. Military assets are often prepositioned in strategic locations to support any number of operations. This process of assessing threat, assessing current assets, and deciding how to reposition is common to both the military and firefighting. This is the same process that we utilized in this research to develop a decision tool for the Los Angeles County Fire Department. To begin a background, here you will see a map of Los Angeles County, California. Los Angeles County is home to over 10 million people and is broken into 5 climactic zones. These zones are named in the bottom left-hand corner of the slide. Within these zones are a series of remote automated weather stations, or RAWs. These RAWs provide weather forecasts for specified regions, denoted by the black lines on the map. Across these regions are 174 fire stations managed by Los Angeles County Fire Department. These are denoted by red circles on the map and are each staffed with an assortment of captains, firefighter specialists, and firefighters. When these personnel are called up from off duty for the day, they cost up to $2,000. Finally, we note that the Los Angeles County Fire Department annual budget is $1.2 billion. For rolling equipment, the Los Angeles County Fire Department uses the Type 1 engine, the Type 3 engine, the Type 6 engine, and the water tender. They also utilize hand crews, which consist of inmates assigned to a bus. The staffing configuration of these engines is also displayed on each photo. Any personnel in parentheses are optional. So for example, the Type 1 engine is staffed by a captain, a firefighter specialist, and 1 or 2 firefighters. To aid in Los Angeles County Fire Department's augmented staffing plans, in 2019, Ensign Zach Scholes developed the Augmentation Optimization Model, or AOM. AOM uses logistic regression to calculate the probability of fire start in each RAW's sub-area. It then uses multiple linear regression to calculate expected burned acreage given a fire has occurred. These 2 regressions are fed into an optimization model that minimizes expected population displacement. While AOM has been of great use to Los Angeles County Fire Department, it is in need of improvement. This research develops a new AOM called AOM with Simulation, or AOMS, to provide a more accurate tool for Los Angeles County planners. The biggest challenge that we needed to fix with the legacy AOM was its inaccurate burned acreage estimates. To solve this, we enhanced problem representation with an acreage containment simulation. Some of the other problems with legacy AOM are that it does not incorporate new predictors, terrain, and accessibility, so we analyzed these new predictors. AOM, on average, takes 6 to 7 minutes to run, so we decreased runtime to 1 to 2 minutes and give Los Angeles County personnel control over their memory usage. AOM also does not have a user-friendly interface, so we create an enhanced input and output design and make all data parameters available to edit in Excel. Finally, AOM does not allow for fixed solutions. This means that Los Angeles County planners can't assess their own solutions. We solve this problem with a fixed solution feature. We began this research by first attempting to see if we could improve Scholes regressions for fire start and burned acreage with the new factors, terrain, and accessibility. We verified that adding these predictors does not improve the logistic regression for fire start. After exhausting the burned acreage dataset available, we also conclude that we cannot accurately estimate burned acreage. This is largely due to the histogram that you'll see on the right-hand side of this slide. We display a histogram of fire size broken into increments of 5 acres. We were given just over 2,000 observations for burned acreage, but you'll see that the vast majority of them burned 5 acres or less. This creates a challenge for predictive models as they cannot discern between what is causing a small or large fire. To solve this problem, we developed the Acreage Containment Simulation, or ACS. ACS models acreage containment rather than burned acreage as a function of prepositioned resources. ACS simulates the arrival of engines and personnel over a designated time period where they lay hose on the right and left flank of a fire. This right and left flank idea is depicted in the figure on the slide, and we calculate acreage containment using the area of this sector. Here you see the containment of a 10-acre area, which is considered a successful initial attack. We simulated over 10 million configurations of resources, each for 1,000 replications. We terminate the simulation after 30 minutes to model initial attack, and the output is an acreage contained in 30 minutes value. Finally, we perform regressions on ACS outputs to replace complex simulation results with a more simple and intuitive method of estimating containment. AOM's logistic regression and ACS outputs are fed into a new optimization model. This optimization model recommends the placement of Los Angeles County resources to minimize an expected loss function. We have sets for each raw sub-area possible resource configurations, as well as binary variables representing which configuration was chosen. We also have decision variables indicating personnel and engine transfers, as well as off-duty personnel being called up to a sub-area. The objective function expresses an expected loss, and this loss balances population density and the expected acreage containment provided by ACS. We also include other tiebreaker and penalty terms into the objective function that give Los Angeles County personnel more control over solutions. Finally, the model is constrained by budget, balance of resources, resources available, etc. This model accommodates hundreds of thousands of variables when there are many sub-areas that receive augmentation. For instance, this past week on December 1st, AOMS featured over 450,000 decision variables. We delivered AOMS to Los Angeles County Fire Department in October, and they've been using it daily and providing us regular feedback. Fire threat was relatively low during October and the beginning of November, but has recently increased. As we mentioned, AOMS is being used every day, and you'll see here one of the output charts that was actually produced by AOMS this past week. This chart shows the trade-off between cost and protection. On November 5th, a fire did start in the Claremont Raws sub-area. Los Angeles County policy dictates that a Raws sub-area can only be augmented if its burning index exceeds its burning index threshold. These two indices indicate fire danger. AOM is tuned to only allow augmentation in these scenarios, but it can be overridden by Los Angeles County personnel. Claremont's burn index was less than its burn index threshold, and Los Angeles did not override the preset, so augmentation did not occur. Claremont had a 24% probability of fire, however, which is significant. We analyzed the burn index to burn index threshold requirement and suggest other rules for augmentation. If we let AOMS be the sole decider in which subareas are augmented, AOMS will automatically send additional resources to Claremont. We also see an increase in expected acreage containment. If we augment based on burning index or probability of fire above 20%, we also see additional resources being sent to Claremont. We're also interested in comparing the AOMS Legacy AOM and Los Angeles County solution for December 6, 2017. This date is chosen due to high fire potential across many regions and was analyzed by Scholes in his thesis. On this date, a fire also burned 422 acres in the Beverly Hills Raws. Both Legacy AOM and Los Angeles County did not augment additional resources to Beverly Hills, but AOMS did. We also replicate AOM solution in AOMS using the fixed solution feature, and we see that AOMS outperformed AOM in both expected acreage containment and expected persons protected. Los Angeles County's solution for the state cost over $186,000 in off-duty personnel alone. We emphasize that AOMS can provide effective solutions for much lower budgets. In conclusion, we find that this research, which uses regression, discrete event simulation, and optimization, provides Los Angeles County Fire Department with an effective tool to guide their augmentation plans. AOMS provides faster, more accurate results than Legacy AOM, and its upgraded user interface and added features allow for convenient and intuitive use by Los Angeles County planners. Thank you. Any questions?